Hi everyone, welcome to the channel. My name is Ernie. In this video, I'm going to show you how to perform unsupervised classifications using the KMeans algorithm in Google Engines. In my previous video, we used the supervised classifications to classify land use land cover. But in this video, I will show you how to perform unsupervised classifications. This classification is a powerful and beginner-friendly approach to classify satellite images without using any training data. Before we start the coding, let's quickly understand what is the unsupervised classification is and what is the KMeans is. First, what is unsupervised classifications? Unsupervised classification is a machine learning technique where an algorithm group data points into cluster based on inherent similarity without prior knowledge of class labels. Unlike a supervised classification, it doesn't rely on labeled training data. The goal is to discover hidden patterns and structures within the data. If we see this image, there is the data without labels, and the machine will be interpretations using the algorithms based on the patterns, hidden pattern or the structures within the data. And after that, the machine will be grouped it in based on into maybe a view class based on their pattern and their structures. And what is the K-means clustering? The K-means clustering is a popular unsupervised machine learning algorithms used to partition a data set into a key cluster where each data point belongs to the cluster with the nearest mean centroid. So if we see these graphs, this is the data without the before the applying the K-mean clustering, and this is the after applying K-mean clustering. So this data here, it will be a cluster based on the nearest to mean or nearest to the centroid of this its data. And this means it doesn't need any training data or predefined levels. Instead, it automatically group image pixel into cluster based on the similarity of their spectral value. And this method is especially useful when you don't have ground truth data and want a quick look at land cover pattern in your region or in your ROI. It can help you identify areas like water bodies, vegetation, build-up areas, or more, depend on how many cluster you want to define. Alright, let's jump into the code. I will walk you through the steps from the loading satellite image, selecting the bands to applying keymeans and visualizing the classification results. And I will also assign different colors to each class to help us interpret the output more easily. First, you should sign in the Google Engines and then go to Code Editor. And after that, you should define your ROI. Today, I will use ROI for my country, Indonesia, Denmark, Regency, and I will add this ROI to the window geometry and make it a center object. Again, then run it after a few moments. Okay, next. Your ROI will be showing in your window. And today I will use data from Sentinel-2. If you want to know about this data set, just click here. You can read in description menu the detail about this data set and these bands. This is the resolutions of these every bands. So today I will use band number 2 or blue bands and band number 8 or NIR and band number 11 to get more informations. If you don't know how to write the code, you can copy here the code and copy to the script. Today I have already write the code. Here, this code is for cloud mask and make a variable, for example, image here, Sentinel-2 filter bounds with our ROI. The date I will use 2023 May until 2023 August and get the median value and clip with the geometry. This one is for visualizations and that I have already mentioned before. I will use band number 8, 11, and band number 2 to visualization to get the more information from my image. Okay, you can see here little times. Okay, from this image we can see that here is blue colors is for the water body. You can compare with the satellite images. Okay, water body. After have the knowledge from the what is false color composite here, you can just extract the raster value from the image. Here, the scale is 10 meters based on the Sentinel-2 and the region is geometry. This is number pixel that I will take how many number pixel that I will get the sample. Here is 50,000 I will use and tile scale is 4. And that I have already mentioned before that I will use KMeans clusterer and 10 is a number of how many class that I will classify. This is the today, for example, is 10 class. And then cluster it from the clusterer. And this is the palette to differentiate every class. So the output, it will be help us to interpret the output more easily. And this code is for add the cluster to the window and just run it. And after a few moment, it will be showing here. And that's it. We have already performed the unsupervised classification in Google Earth Engine using KeyMeans. And if you want to see detail or Just see here, if you compare with the satellite images, or here and click here. So this area, the pink color is for the urban area, you can see. And the blue colors is for the water body. And this area or brown color is for the forest area. So from this image, you will have first about your land covers class before you do the supervise. If you want to have the first what is land cover in your ROR, you can use this classifications, because if you use the supervised classifications, you should take samples for training data. But here is very very simple. So, and of course, interpreting the output is a key because the algorithm doesn't label the classes for you. So you will still need to match the cluster with a real world land cover types, possible possibly using visual inspection or reference data that I have already showing to you. And that's it from my side today. If you found this video helpful, don't forget to like, and thanks for watching, and see you in the next video.